So if I write this y22 v2 is equal to minus y21 vs. So v2 is equal to minus y21 divided by y22 vs. Now substitute this v2 in this equation. Now it is I1 is equal to y11 vs plus y12 into v2 is minus y21 divided by this y22 into vs. If I take this vs as a common here, it is y11 minus y12 into y21 divided by y22. So this is equal to vs into y11 y22 minus y12 y21 divided by y22. This is equal to I1. I need to find this vs by I1 here. So this vs by I1 is equal to, from this, y11 y22 minus y12 y21 divided by y22. Normally this is represented as delta y divided by y22, where delta y is equal to, it is the determinant of this y matrix or short circuit matrix or admittance matrix, that is y11 y22 minus y12 into y21. Okay, now this is let me take this one as I already represent another equation. It is first equation, second equation, so it is for reciprocity, so I can take this as first equation. Next I am going to calculate, I am going to measure the ratio of response, the ratio of excitation to the response at the other port. Now the ratio of voltage, this excitation to the response, response means current, it is current at port 2, Now this is the two-port network, and in calculating this one as it is v2 is equal to vs, it is v2 is equal to vs, and it is I2, this current is I1, and plus or minus it is v1. Now I need to calculate here vs by I2, and these two ratios should be same for the networks which are in symmetrical. So if I calculate after calculating this vs by I2, I need to equate this vs by I1 with this vs by I2, so that I can get the condition for symmetricity in terms of y parameters. Okay, so try to use these expressions here. I1 is equal to y11 v1 plus y12 v2. I2 is equal to y21 v1 plus y22 v2. Now, so in this I1 should be equal to 0 because it is open circuited. So let me write the conditions here. V2 is equal to Vs and I1 is equal to 0. If I substitute in these expressions, what I need to find? Vs by I2. So I need to use this expression here. If I substitute here in terms of I2 is equal to y21 v1 is v1 plus y22, it is v, instead of v2 I need to write vs, but v1 is here. I need to replace this v1 in terms of this I2 and vs. So I will get this from this I1 is equal to 0, 0 is equal to y11 v1 plus y12 v2. From this v1 is equal to minus y12 divided by y11 to v2. So this is v1. If I substitute in this equation, then I will get I2 is equal to y21 into v1 is minus y12 divided by y11 plus y22 into sorry, into V2. Here it is V2. So instead of V2 I need to replace with Vs. So it is Vs. So it is Vs. y22 Vs. Now let me write this expression. I2 is equal to minus y12 into y21 divided by y11. So I2 is equal to minus, sorry, what is that, y12 into y21 divided by y11, y12 into y21 divided by y11 into Vs plus y22 into Vs. So this is the equation. From this, if I take Vs as a common, Vs into y22 minus y12 into y21 divided by y11. So Vs into this y11 into y22 minus y12 into y21 divided by y11. So it is I2. Now this ratio of voltage to the current or excitation to the response at the other port is equal to y11 y22 minus y12 into y21 divided by y11. That is equal to delta y divided by y11. Let us consider this one as equation 2, this one as equation 1. I found this Vs by I1 and Vs by I2. Now from the symmetricity, from the condition of symmetricity, condition of symmetrical networks or symmetricity, this Vs by I1 should be equal to Vs by I2. That is equation 1, it should be equal to equation 2. Vs by I1 that I calculated as delta y by y22. So it is delta y by y22 should be equal to Vs by I2 is delta y by y11. This delta y will get cancelled here. So finally what I get here is y11 should be equal to y22. So this is the condition for symmetrical networks in terms of y parameters.